6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. And it has cleared the tower.
Prepare yourself for a world of science.
Good morning, everybody. Conley here with the Science Nights in the Morning. We got a full house today, and we are really looking forward to talking a little bit about the stars and the cosmos. And, you know, it's very special being out here in the high desert. And we see the night sky really as a gift, really, and something that we can easily gaze into and kind of just live in wonder every single night whenever we go out and look at the stars. Here in the studio, we have Dr. Anirban Bhattacharjee all the way from Australia. We also have Dr. Sean Graham, and we have Dr. Thomas Shiller with a very special guest here in the studio. Tom?
Yeah. My new friend, Jean-Philippe Uzan, or JP as we'll call him, so we don't butcher his name with our Texas accents. JP is an astrophysicist from France, and he's visiting West Texas through a residency program, Villa Albertine. Mm-hmm. And he is interested in our Texas skies and a bunch of other stuff. So a couple of weeks ago, he and the 3 other residents in this program came out to Big Bend with me, and I gave him a nice tour of Big Bend National Park, and we got to see some of the beautiful West Texas night skies on that trip, and hopefully it made an impression, but we'll see what he has to say. What do you think, JP?
Hello, everybody. So yes, it's so this time in Texas is a very special visit for me, because usually my work is doing research, so I spend my time, in an office with a computer and papers and these kind of things, and a lot of mathematics. But I was offered the possibility to visit Texas for a residency, so we are 4 of us, and the other, our friends are artists. And of course, they wanted us to think about this idea of new space and rethinking all these ideas about going back to space. Because, of course, this is an idea which is related to space research, to science first. But there are a lot of issues about economy, about should we go there? The connection between the private and the public. And, in Texas, there is a huge history in connection with the race to the stars, and in particularly during the Apollo program. And today with the private company who are in Texas trying, to build their own space launch. And this is at the same time something, I think there is this ideas of this new space was emerged at the end of the 70s. There was a book by Jerry O'Neill in the 70s called Higher Frontier. Mm-hmm. And this book inspired a lot of young guys like Jeff Bezos, for instance. And these young guys, they try to make it through. And the question is this where we want to go all together? Because as you all know today, we have realized that, the planet is kind of short of energy and metals, and there are all these issues and problems that we are discussing all together. And is this a time to go back to space, to the moon? What are the reasons? Are there scientific reasons, economical reasons? Should we find a way to go, all together, to collaborate all the countries, or should it be a new race between, I would say, the States, China and Russia? What is Europe playing in this game? So all these questions, we try to address, and also to see how we can make that very real for people. And this is where the art part, is entering the game, because most of these things, when you want to reach new frontier, it's coming through dreams. And dreams are the ideas that you put in the head of people, and it drives them very, very far away. And sometimes you cannot explain, scientific fact directly, and you have to find, sidewalks to explain them. And usually I give an historical example for that, which is very dear to my heart, is Johannes Kepler. He was one of the most famous astronomer of the 17th century. And in 1634, he wanted to explain to the people that, the Earth is rotating on itself and around the sun. He knew the maths. They were probably on Earth 5 to understand this kind of maths. There was no evidences. The evidences came 150 years later. And he got the idea to write a fiction. And in this fiction, he's traveling to the moon with some kind of, his spices and stuff like that. It's a bit esoteric. He's flying to the moon, and he observes the moon. He observes the Earth from the moon, and he described the Earth from the moon and the motion the Earth had. And of course, he thinks that there are some selenites, some people who are like the stone, some people who are living on the moon. And he meets them and describes because he knows everything about gravity, so he can understand, the planet is smaller and less weight, so gravity should be this. So he was describing everything as if he had been to the moon. And you see, when you know physics and maths, you can travel by your mind because you can put yourself in the environment where you want to go, and then you can write a story. This is a fiction. But once you have a fiction, people will read it, people will discuss about it. They won't understand the mathematical details behind that, but they will start talking about it. And as soon as you start talking about things, then it becomes common culture. And eventually, years later, you will start to study it and to make a common knowledge. And I think all these things to play with fiction, to play with art, to explain the difficult ideas of the world we are living in is something very important, because we all know that if we want to understand astronomy and quantum mechanics and all these things and paleontology, it takes years, to sit in a university. And the knowledge does not have to stay in a university. It has to be brought to the people in different ways. So this is one of the things we are trying to do. And I was very interested because on the margin of my research, I do a lot of popular science in France because I think this is something very important, because we need scientific culture to go to everyone, and for the knowledge, because it's beautiful, but also for political reasons, because, at some stage, if you don't understand the nature as we understand it in the 21st century, how are you able to take political decisions?
Yeah.
You have to live in your world. And this is why I've been very interested by doing this kind of things.
Well, we are really happy that you're here. And we've had on the show before Pat Dash.
Oh,
actually, you were talking about dreams and fiction and manifesting what isn't reality now and manifesting it into reality through science and through knowledge and education. This kind of hive mind that we have generations and generations and generations of, that we kind of pull from in order for us to keep making that progress, right?
Exactly.
Well, now, Pat Dash mentioned that Buzz and Neil came out here to kind of simulate a lot of things that they might see in the unknown. And what makes the Big Bend area sought after? What makes it a destination?
Okay, so maybe, Tom, you can also explain that, because...
Sure. Well, JP and the rest of the crew went out with Pat. Was it last Tuesday?
Yes.
And actually, we haven't had a chance to really talk about that. So what was that experience like? Pat Dash, for those of you who haven't heard our episode with her, is probably the number one expert on that training mission that the Apollo astronauts did out here in West Texas. Basically, what they were doing is learning how to do fundamental field geology in a lunar setting. So what a better setting than our desert landscape out here. So they learned how to collect rock samples and things like that. And Jean-Philippe, you spent a day with her last week. What did you think about that?
It was fantastic, because she has, this insider view of the history. You can read history in books, but when you meet someone who has lived the events, you get a flavor, of how intense this story was, and you get, some kind of small stories and the difficulty they were. For instance, this idea that in Nevada they have to, they were making artificial craters that would look like the place they wanted to land in the moon, to train. And then you ask your question, okay, so they did that, and it was, in the 60s. So you take an area that you think is a desert, but I've learned also, like, spending time in these places, and also last weekend when I was in White Shaman, that what you think is a desert is not a desert. You can find a lot of tools, and our guide, she shows us how you can make needles and thread out of some plants, and how you can find food and so on. And you know that, 2 centuries ago, it was packed with people here and in these places. So this idea about how you conceive what you look at is something very important. I think this is something you learn when you do science. The first thing I tell my students about science is to learn to look. And usually you cannot see what you are not expected to see. Things remains invisible unless you are prepared to see something. And to me, people who have made great discoveries in the history of science is people who were able to see something that was just in front of the eyes of everybody, but they were blind. So we learn not to be blind in science. And one of the key issues is this curiosity, this fact that you take a stone and with your hand and you ask what it is, and you take a plant, like kids. And I've been a father and now they are grown up, but I always like, these ages when they always ask the why question. Whatever you say, there is a next why question. And sometimes it's a bit upsetting. And then we send them to school. And of course, they learn a lot of things, but sometimes they lose a little bit of their curiosity. And I would say it's very important to keep this curiosity alive, because this is what makes you, someone who just takes the knowledge not as something that to be better than the others, but the knowledge to act in your world and to ask questions to nature. And to me, when I was a kid, this was my chance. My parents didn't go to school or university, but I got a chance to have, teachers that try to say, okay, you're asking a lot of questions, just go on asking questions like that. And it makes you happy. And for me, it's also something very important. And I think Pat Dash also had this feeling about, trying to bring her knowledge to other people. And as you know, you are also teaching. I think to me, it's one of the most beautiful things that when you teach, you take your knowledge and you give it to other people. Of course, they have to work, but you give them your knowledge. And it's magic, because you can give something and at the end of the day, you still have as much knowledge as before. So you use your knowledge, and the more you use it, the more it spread. And it's like never ending thing. So it's like one of the resources on earth that you can use and will never disappear. And I think this is where we will find solution for the future. And we need these young minds and, these young people who will come to university and try to put them on subject that will trigger their interest. They will learn, but it's not enough. What I think is important is to give them, dreams and things they really want to do, which matter to them. Because if they do that, they will get a lot of energy. And this is what we need to decuplate. When you are a teacher, this is something you like. And I've seen that Pat Dash is doing that a lot, to try to bring awareness about our planet in the solar system, the moon. And, it's kind of obvious for a lot of people today about this planet being a sphere, and the fact that outside is something that you cannot go and it's difficult. We have seen a lot of movies, but I remember the picture of of 69 archive picture when you saw all these people gathering around televisions all around the world, watching this thing, which is like a moment in history. You are doing something that no one has done before. And this was not an American, it was a human. And to me, this is, everyone was there, everyone was concerned. And the world was different after this that it was before. We knew the moon was there. Scientific explained to us how important the moon is, to stabilize the Earth for life conditions on the Earth. We knew very little about, timeline on the moon. This is why we needed these rocks to understand better the geology. And I think the samples they brought back allow us to calibrate the chronometer of the solar system. And this is very important for us to understand, the history of the moon, the history of the Earth. The two bodies are, intertangled. But also we got this marvelous picture about the blue marble and what it brought to people like Carl Sagan when he's writing the pale blue dot. And for a lot of people, this is the beginning of the ecological, thinking for Europeans, I would say. The fact that we realize we are on the same planet. This planet is like a space shuttle. This is also we don't see, because we are here, everything. We don't move. And then we realize, yes, but you are speeding like 30 kilometers per second around the sun. Each year, each time you have your birthday, you have one turn around the sun. And the solar system is going around the galaxy, and it's like about 250 billion years to go once around the million years to go around the center of the galaxy, which means the Earth has done probably 18 times around the galaxy. I mean, this is quite a trip. And when the dinosaurs you are studying, we were not in this place in the galaxy. No. We were in another place. And when you start to think about like this, the world seems so large. There are so many things you want to grasp that I think you are full of energy, to go and discover. And there are still a lot of things to discover.
And that's something we've talked about on a couple of previous episodes. Whenever we talk about space exploration, is the cultural impact that it has. Like in the 60s, that was the collective obsession of everyone, especially in the U.S., sending the Apollo astronauts up. And I'm hoping and I'm wondering if this new push to send people back up into space will reinvigorate that sort of cultural renaissance that we had. Because I think it did really good things for science in general, inspiring young people to pursue careers in science. But I think it also kind of lifted everyone's collective spirits when it came to humanity and what we're capable of. So, and I think Sean probably mentioned this on a previous episode. You see kids, college students and high school students wearing NASA shirts, which is really cool. Yeah. Right? I think you mentioned that.
Yeah. No. Yeah, and that's one of the things that doesn't often get said. I just recently read this pretty good book called One Giant Leap. It's a recent book about the Apollo program. And, you often hear about the fringe benefits of the space program. And there's this myth out there that it gave us Tang and that it gave us Velcro. And neither of those two things are actually true. They were both invented before Apollo. But what it did give us, which isn't mentioned enough, is rather than push us into the space age, which we thought it was going to do, it pushed us into the digital age. Mm-hmm. That's actually what it did. Like in '69, who do you think was the primary, consumer of microchips?
Oh, wow.
It wasn't IBM. Yeah, it was NASA. And even though they had those, terrible computers that couldn't do anything but what a large calculator could do to run those spaceships, they were the only ones making anything like that. And those startup companies that started producing that stuff at that time, that triggered the digital age. It was Apollo. It's amazing. That's a little known fact that I was like, of course. And it blew my mind. And that rather than a little fringe benefit that people kind of laugh about, like Tang, we wouldn't be talking right now on this computer the way we are. That would have came decades later if it hadn't been for Apollo.
And another thing people also forget is like the solar cells. That was also related to space-related spacecrafts being sent up, and you wanted to put like renewable solar cells up there, and how that became way more efficient nowadays because the research started because we wanted to put solar cells on our satellites. So that started with that field. So. Yeah.
Wow, that's awesome. Well, we're going to go into a quick commercial. Y'all are making me want some Tang right now. But anyway, let's go into a quick commercial break. We'll be right back, and we'll be talking more about the cosmos.
Hey, everybody. Science Nights in the Morning. We're back. We're back with JP, Jean-Philippe, an astrophysicist and cosmologist from France, who's visiting West Texas, and we're talking to him about the wonder of science so far. JP, tell us a little bit more about, it's really remarkable what you're doing in West Texas, kind of merging science and art, looking into ways of communicating science to the future generations, which is kind of what we're trying to do here on our show. But what do you do for your day job? What's your career in astrophysics like?
In my real life, you mean?
Yeah. When you're not on vacation.
Okay, so officially, I work for the CNRS. This is a French National Agency for Research, and I work in an institute which is called Institut d'Astrophysique de Paris, so Paris Institute of Astrophysics. And in this institute, we are a bunch of theoretical physicists. So I was brought up as a general relativist. So my specialty is a theory of gravitation, that Einstein wrote in 1915. And so I've been working on black holes quite a lot, and I've been also working a lot on the Big Bang model, like on TV, Big Bang theory. So now I've been working on these things for more than 25 years. And as you know, there are a lot of new experiments coming out, in particular to test whether dark energy and dark matter do exist, what are their properties, and there is a satellite. So we got the GWST, which is a little bit away from what I'm doing. It's more about the first galaxies and also exoplanets. But there will be a satellite launched next year, which is called Euclid, and it will do what we call gravitational lensing. So, gravity, so every mass bends light, and you can measure that. It was we made the first measurement in 2000 from the Canadian France-Hawaii telescope in Hawaii. And now it's been measured by a lot of teams, a lot of telescopes. And we understand that because you directly measure the wrinkle of space-time, so the geometry of space-time, you can have you can have a measurement of the matter which is present in the universe, whether it shines or not. So you see galaxies, they shine. You see stars, they shine, but you have all this matter called the dark matter, which is probably one of the most dominant part of the matter of the universe, who doesn't shine. But it cannot hide itself. It will bend space-time and light, so the shape of background galaxy will be deformed, and this is what we are trying to measure. And this is really the next step of cosmology, and on this experiment there is about 1,000 people working on the experiment all over the world, if you count technicians, researchers, computer scientists, so it's a really big experiment. But we hope it will push us one step further on the understanding of dark matter. And
you're involved in the production or the launch of this spacecraft, the Euclid?
No, I've been involved on the theory part of the experiment, in particular at the beginning. It started the PI, so the principal investigator, the guy who is running the experiment, was a researcher from our institute, and around 2000, when he made the first measurement of weak lensing, we had discussion and think that the next step is to go to space, because you don't have atmospheric problems, and also you can do like a very large scale measurement, and this is what you need to do. And we tried to start building the science case with him and some colleagues in France, and then people from all other countries joined the project. So there are, it takes about 20 years to make the scientific case and build a satellite and launch it. So this is also something people do not realize. You just do not have an idea and you launch a satellite. It takes 20 years before you actually argue to agencies that this is worth funding these things. There are a lot of experiments which are competing. Once in a while they select one, and then you have to work with technicians to actually reach the quality of the measurements you need to reach to make your science. And then you have to build it, and then you have to launch it, and then there will be a huge mega and teraoctet of data that you will get to analyze, which means that you also have to develop all the software you need for that. And at the end, you get with scientific analysis. Just to say for the younger that if you are interested by space and cosmos, you don't need to be like the first in math in your class. You can go through engineering, computer science, managing. There are a lot of people in these teams, and they are all interested by better understanding of nature. But you don't need, to be like Einstein or Stephen Hawking or whatever to help make a progress, because today this is really a thing with teams. So I was more on the theory part because I've been working on general relativity for years. And now we got some ideas of what kind of test we can make, not only to see whether dark matter, we can improve the knowledge about dark matter, but also whether we can test the theory of Einstein on cosmological scales. It's very well tested on the size of the solar system. And actually, for people in Texas, the McDonald Observatory is part of this. During the Apollo mission, they put 3 mirrors on the moon, And then there were 2 Soviet mission, Lunokhod, who put 2 other mirrors. So there are 5 mirrors on the moon. You shoot this mirror with a laser beam. So one from McDonald's, there is one from France close to Nice in the south of France, one from Austria, one I think from Australia. And you measure the time for the laser beam to go from Earth to the moon and come back from the FAM station. And they've been doing that for 30 years.
Wow. And
what to test is that whether the Earth and the Moon are falling exactly in the same way in the gravitational field of the Sun. And this is being tested at the level of 10 to the minus 13, so 0, and you put 1301, 1201. So it's a very high precision. And this, if you find some mistake there, discrepancy with the fact that it has to be compatible with 0, it would mean that general relativity is not a good description of gravitation. So people have been doing that more and more, and we have improved this by a factor 100 recently with a satellite I've been working on, which is called Microscope, with a European satellite. But you see here, they are making some observations that allow us to test general relativity, and it's just next door.
Mm-hmm. And talking about dark matter and dark energy, the observatory out here, they have been doing that with the BOSS survey, with the baryonic oscillation survey, and I think they are also running the dark energy survey right now, and on that one too, with the Department of Defense or something like that. I think that's still going, right? The dark energy survey is still going.
Yes.
Yeah, the BOSS is complete.
Yes.
Yeah, that one is complete. I wanted to mention like an anecdote. I don't know, when you said you did general relativity, I had to take a class from Glenn Repka. So yeah, he was one of my professors. So he passed away. So he was really old when I showed up. And also when you're talking about cosmology and dark energy, I'm not a dark energy person, so my work is in quasars. Mm-hmm. So one of the things I always you have to tell me now, is this something when I tell my students is wrong or right? So when I say when I tell my students at the end of the class, it's very hard for us to know or predict how dark energy at this moment will do. Maybe in the future we can say these are the things that dark energy can, how it will affect. It might slow the universe down, or it might accelerate, or it might just not do anything, or it will continue just as it is. Am I telling my students wrong, this thing about dark energy? Because I didn't study dark energy as a field of research, right? Because to me, it feels like, even for me, it's like you're telling me something where the scale is very, very big, even for a time scale, like a billions of years, right? Mm-hmm. How would we be able to, for me, in my views, how would I can test it on a very small scale kind of thing?
Okay. So the first thing is to realize that this idea that there could be something like high energy was understood in the 30s. Mm-hmm. Georges Lemaitre is the father of the Big Bang. He had these ideas that you can have what he called the cosmological constant. He actually came to the States. He wanted to see Hubble, because he was very interested to see how well we can prove that the universe was expanding, because he made the prediction. The Hubble law that was actually established in 31 at Mount Wilson Observatory was renamed as Hubble-Lemaitre because he made the prediction in 27 about what you should see. And people have going on, trying to understand, to map the expansion of the universe to deeper and deeper time. And one of the big issue here was in the end of the 90s. They make this supernova experiment, and some people got the Nobel Prize for that. Yeah. And then it showed that the expansion is accelerating. Mm-hmm. So this is an observational fact. If you think, of course, you have all these caveats about understanding of supernovas, but admit that we understand supernovas and what they have done is correct, which I think it is. Then you have an observation which is the universe is accelerating. Then you ask yourself, is it possible? And then if you say, I believe that gravitation is well described by general relativity, then you need to have a matter which does not exist in laboratory, because all matter we have in laboratories, they have positive pressure. Mm-hmm. And with positive pressure, you can never get accelerated expansion.
Yeah.
So once you have said that, there are two possibilities. Either general relativity is a good theory to understand the geometry and evolution of the universe, in which case you have a new piece of matter that has to be understood, or this matter does not exist, which means that general relativity has a problem. Whatever. This key observation, and we have now a lot of cosmological, astrophysical observations that go to the same direction. They tell you that one of the important things in our understanding of nature, the theory of gravity, Einstein theory, or there is a new kind of matter in the universe. So we don't know which is the solution, and this is why we're making this experiment. And when we do like these experiments, we test some models of dark energy. We also try to extend the test of general relativity to see how well it describes gravitation. Yeah. But I cannot tell you what will be the answer because this will be the future. And I'm sure that once we got this answer, it will probably lead to a big revolution in science, because if we could discover a new kind of matter that we have never seen on Earth, there is a known unknown, as they say, but there are the unknown unknown.
Right. Yeah.
And we have to deal with that. This is life.
Yeah, that's something I've always kind of, that kind of changed my life, that awareness around that, the more esoteric dreams that you have and the more outcomes you want, the more esoteric problems that are going to arise from reaching that, creating something that's never been built before or doing something that's never been built before. There's always going to be something new that's coming up. And that's a beautiful waltz that we have with the information that we collect and what we know now. So it's awesome. So, all right, we're going to go have a quick commercial break. We'll be right back for another segment.
All right, we're back with the Science Nights, and we're talking with Jean-Philippe Uzan, a cosmologist, astrophysicist from France, and we've been talking about some sort of way out there technical, physical things, and I just wanted to ask, what got you into cosmology, to studying the cosmos?
I think it was mostly chance, As I said before, my parents never studied. I was born in the suburbs of Paris, 15 kilometers from Paris, so went just to public schools, and actually I was kind of easy with math, and the teacher told my parents, he has to do some studies, and I went through, and at some stage, I went to university and I was studying math and physics. On the side, I was also studying anthropology because I was very interested by the people from the far north, the Inuits. So I didn't know exactly what I would be interested in. I learned what I loved was to learn, whatever, geography, astronomy, mathematics, biology. I was really, I wanted to learn. And it was in a time where there was no internet. There was very little number of popular science books, and there was not all these clubs, of astronomy. So I never did astronomy as a kid. And I discovered that when I was like 20 or so. And through university, I met some people, and then I met my PhD advisor, and she was specialist in general relativity. She worked on the binary pulsar, and she was quite famous. And she told me, I've been doing a lot of general relativity, but now I want to go to cosmology because this is something which is starting. There were people, especially in America, who were quite, in advance compared to France in cosmology. You got James Peebles, who got the Nobel Prize very recently. There were a lot of, well-rooted universities studying the cosmos since the 20s, 30s. But in France, the community, we had a community of astrophysicists, particle physicists, and theoretical physicists. And in the 90s, they decided to make the Planck satellite. So the Planck satellite is a satellite that was launched to make the measurement of the cosmic microwave background. You get WMAP in the States, and a couple of years later we got the Planck. And because the States was going to this big satellite, they needed people doing specifically cosmology. And this was just the time I was doing my PhD. So it was luck. I was just there. I got the math, I got the general relativity, the particle physics, and my PhD advisor told me, okay, we are going to cosmology because this is probably the next field in astrophysics where there will be a lot of discoveries. I defended my PhD in 98, and if I think the changes of our understanding in the universe in 25 years, we got this acceleration of the universe, dark energy. We got the discovery of gravity waves. The
2017, right? Yeah. There's a lot of things that have come out we didn't expect to happen. So things have changed a lot. And then even like, which is not cosmology, if you look into people who are doing exoplanets, they love it because Kepler has changed completely everything on their front. So things keep pushing, and we keep on asking questions, right?
The question you're exploring now, especially involving this trip to West Texas, is how do we translate that to younger generations? How do we inspire younger generations using music, visual art?
Yes, that's one of the issues. How do we try to do that in a way that is not controlled just by a few people, that we're trying to go there collectively? Because there is also one issue about science. I mean, like if you take a stone, you drop it, it falls. I mean, this is a general laws of nature. And this is what we would call a universal knowledge. And we have laws, and we are supposed they are universal laws, but they are not the only knowledge we have. They are, like the people, the natives, they are their own knowledge of nature. And then we realize that you have to take all these knowledges from all people over the world because they give you different insight of the universe. They don't have the same level of explanation of the world, and you cannot take just science as the only explanation. You have to mix them. And if we want to go back to space, then there are a lot of ethical questions that we have to raise. And to me, this is also where the key point is. Because we are in a world where we say we need to go for innovation, for new things all the time, new discoveries. The question is, what are the use of this innovation? And there is someone I love that was professor in Princeton with Freeman Dyson. Maybe you know him. He wrote a lot of popular science books. He died a couple of years ago. And he said, he has a question, is science good or bad? And he said, he had an answer. He said, I would say that science is bad if its goal is just to make toys for the rich. But if it's to help to all of us to live better on this planet, then science is doing good. And the question is, why are we going back to space? If this is, to do mining of asteroids and go on polluting around the Earth and so on, is this what we want to do? Right. We know that we have all these debris of all satellites around the Earth. It may be a problem. How do we deal with that? What are the laws that we have on space? I mean, there is no international law of space. Is the first able to take whatever he wants on the moon, which is just, 300,000 kilometers from here? So all these questions, which are ethical questions, are also questions we want to ask. And to me, a way to attack this question is to use fiction, because if you take science fiction, you can take the knowledge as we are, you push it a little bit further. And because it's fiction, you can ask questions that if you ask it, on the TV or whatever, people say, this is horrible. But this is not. And if you look, many movies of science fiction, they are kind of experiments about what is the near future of humanity. Mm-hmm. And I think we are in a time where we have a lot of technology. Some people are launching their own satellite. They have the Starlink satellites. I mean, to me, as an astronomer, this is a disaster. If we go on like that, and China is doing the same, maybe we cannot do astronomy from the Earth. So we have a choice to make. And this choice is, where do we want to go collectively? And this is also the question we want to have. And if we have the new generation, they have to know what are the ideas, the dreams, the technology, but also the way to do things. We know that the planet has not infinite resources in terms of metals and energy. What do we use for? What do we choose together? Mm-hmm. And I think once we reach the question of space, it's not just the question of one country doing something in its lab, on a local scale. This is a global scale. So it tells us, well, this is the skies of everybody. We have to find a way to collaborate. And what we see from the world is that it's so difficult for us to discuss about that and to come to an agreement. And this is what I would like also, to reach, is how can we find procedures so that before someone is making a decision that impact on the all people on the Earth, people have a way to say whether they want it or not.
Yeah, and
it's a question even about democracy on the planet and on different countries.
Mm-hmm. You mentioned something a little bit earlier, and we'll wrap up with this because it was very interesting. So Sean Graham is a biologist extraordinaire. He looks inside, like at the microscopic level. There's a whole universe inside a microscope. And there's a whole unknown universe that is among us right now that we're still barely even touching the tip of the iceberg that we're trying to discover, right? We have Anirban that's looking out, and you looking out into the cosmos, discovering things that have never been discovered. And then we have Dr. Thomas Shiller, who's finding the history inside our own Earth, digging up different dinosaur bones and organisms from, an unknown past. And as we look out in science, we're also looking in. And you mentioned something that I believe every single artist, any kind of artist out there, will ask themselves at some point. And I really do believe that science and art, there can't be one without the other. They're always dancing in concert with each other. And what you said, the reason why you got into cosmology is through chance. But what artists often ask themselves, and what is the definition of their journey on this earth, is the dichotomy between fate and free will. What is your definition of that?
It's a very difficult question. It's a very difficult question.
Well, that's what artists struggle with constantly.
The issue about free will started from I would say in the 18th century, when we got this first law by Newton. We saw everything is deterministic. And if we go through the purely reductionist way of thinking, you would say, and that was this idea in the 70s, 80s of the theory of everything, that you will take, things to pieces and the fundamental laws, and actually everything is written from initial conditions, probably at the onset of the Big Bang. And then if you say that, you say, so I cannot decide just to drop this bottle right now. Everything has been done. And this is where we have understood, I think, in the last decade, that this is more complicated than that. There is chance, there is free will, but there is also contingency. Yeah. It seems that we have, like science, fundamental science tell you the space of all the things that can exist. It doesn't tell you why they exist, because you have to take into account the effect of the environment. So, for instance, if you want to have life, you need some kind of molecules and some kind of atoms. It means you cannot be anywhere in the universe. In the early universe, it doesn't exist. If you are outside of a galaxy, there is not enough matter. It doesn't exist. You don't look for life here. And then this is not enough. We don't know all the conditions for life. And then if you think like that, we realize there are some kind of thresholds. And at some stage, we are reaching the scale of complexity, and we don't know why. We don't know. If you take particle physics, there is no hint of information. There is no hint of life. There is no hint of consciousness. It's not there. No. But in our world, it's there. So the Big Bang model tells you that there is something to explain. It's the origin of atoms, the origin of stars, the origin of life. So when Thomas, give us insight about when life has appeared on Earth, it gives me some kind of challenge, because I need to, the universe as an age, you need to have time, to form this first molecule and all these things. It gives you constraints. And when you say that, life has appeared and then consciousness has appeared, this is something you really need to, you have a lot of constraints on that, and we don't understand. And all these questions, which are the question of origins, they are questions which are at the boundary of different disciplines. You need to work a biologist, a paleontologist, and probably a physicist. And then you have to, someone working on the brain, and a chemist. And this is one of the key issues, is that these are very difficult questions. You cannot just have, bottom-up constructions. What you usually do is top-down. You have complex things. You break it to see how are the pieces made of. But you realize that it's not enough. There is something emergent. And the question of emergence is one of the most difficult questions we have in science today. And it is how we relate the different disciplines. How do we relate physics to chemistry, chemistry to biology, biology to ecology and paleontology, and so on and so on. And they are all questions of origins. And this is where they are fascinating questions. And also it needs you to go outside of your pure disciplines, which makes you have to take risks. You cannot just be a physicist. You need to discuss with a biologist. Right. And then you are in danger, because you are talking of things you don't understand. And I think for younger people, what I would say is that this is what is beautiful. Take risks. If you just, work in your discipline, you will probably get very famous results in your disciplines, but probably you won't attack the most difficult problems, the most challenging. And most probably you will fail. But it's not important to fail, because you will have, got where other people have not gone. And this is what I think is a driver in life, just not to become famous. I mean, this is not the key issue about this, is to go and you see in the history of science, people who have remained in their own discipline, in their backyard, and they have done very strong discoveries, very important discoveries, and dreamers that say, no, we have to put this and this, and they were, doing things in a very dirty way, but they open new way of thoughts.
Yeah.
And that you can do. And this is what, as teachers, I think we also try to do, not to say just don't study only maths and physics, but take some biology course, take some psychology course, because all these things, it will nourish you so that your own discipline, you will see it through different lenses, and you will be stronger and more open. And this is what we want our students to be.
Yeah. Follow your heart.
Yes,
follow your heart.
Exactly.
And you can always go out into the middle of the desert, meet Terlingua Terry. He'll give you something that'll pry open that third eye, and you'll find the Serpent Queen out there, and she'll tell you some stuff you might not.
Man, I got something for you over here. I got some.
There we go.
I got some cactus stubs for you, man. You'll see God.
Why do you have cactus tubs?
It's Terlingua
Man, I
Terry.
went and hunted them up. Found me some cactus stubs.
All right. Well, that's our show, everybody. Thank you so much. And we'll see you next week for another episode of Science Nights in the Morning. Thanks for listening to this episode of Science Nights in the Morning. Be sure and follow us on Patreon for exclusive gear and uncut episodes. Check out the latest science articles on our Facebook page and subscribe to us on YouTube and your favorite podcast listening app. You can also listen every Saturday at 10 a.m. Central Standard Time at BigBenRadio.com. And if you got a question, we'll join the discussion. Hit the hotline at 432-217-1983 and record your message. We couldn't do this without you, and thank you so much for listening each and every week. That's Science Nights in the Morning with a K, and we'll see you next time.